Hi everyone, I'm Gina and I am the SI for Biochem 100, and this video is going to go over the Henderson Hasselbalch formula as well as how to infer the pH and pKa relationship from it. So this is the lovely Henderson Hasselbalch formula, and we can use this to figure out if you would have more pH or more pKa depending if you had more base or more acid. To make things a little bit easier, I'm just going to say that the pKa in this case is going to be 5.0. And we'll start off with the first condition that we'll look at, which is when you have equal parts of base and acid. Just to make things a little bit easier to visualize, I'm just going to assign each one the number 1 since they're equal right now. So solving for the log part of the formula, the log of 1, since it's 1 over 1, is equal to 0. So now I'm going to rewrite and plug in what I know for the Henderson Hasselbalch formula. So pH is equal to the pKa, which is right here, 5.0 plus log base over acid, which we had figured out right here. So it's plus 0. The pH is going to be equal to 5, and since that number is equal to the pKa number, when you have equal parts of base and acid, pH is going to be equal to the pKa. So now let's look at another condition when you have more base than acid. To be specific, for this example, we'll say we have 2 times more base than acid. So this number 1 up here will turn into number 2, and now we can solve for log. So log of 2, I calculated to be 0.69, and now we're just going to plug and chug. So the pH is going to be equal to the pKa, which is 5, plus the log that we had just figured out to be 0.69, and the pH is equal to 5.69. 5.69 is greater than 5.0, so when you have more base than acid, the pH is going to be greater than the pKa. To explain this further, when you typically have more base, you're going to have a more basic environment, and when you're in a more basic environment, the pH is going to be higher, something greater than 7 typically. Now let's go over when you have more acid than base. And again, we'll say specifically 2 times more acid. So I'll change this number of base back to 1 and our acid to 2. So we would solve for the log of 1/2, which is equal to negative 0.69. If I plug and chug, pH is equal to the pKa, which is 5.0, plus the log, which is negative 0.69. When you calculate it, you get 4.31, and 4.31 is less than 5.0, so the pH is going to be less than the pKa. This also makes sense because the more acid you have, the lower your pH is, typically less than 7. Thanks for watching.